Good morning, ladies and gentlemen. Welcome to this webinar number 5 in a series of 6 regarding ENTSO-E Vision 2030. This webinar is going to focus on innovation challenge for the system of 2030, as well as on development of AC and DC grids by 2030. I will introduce first the housekeeping rules by saying that the speakers will only have the mics and the camera on they speak, and afterwards they will be asked to switch off the mics and the cameras, and the participants, please go and place your questions directly into the Slido. So we will use, as for the previous webinars, Slido, and not into the GoToWebinar. Feel free to vote for most relevant posted question. Indicate also your name and the company and the institution you belong to. And at the end, we will have a Q&A session, which is going to last for 30 minutes. But please post your questions during the presentation. So in these 30 minutes, we will start to address directly. We will not use the chat and raise the hand feature. So here it's actually the application you can use for your mobile phones. And I would like actually now to give the floor to Håkon Borgen, ENTSO-E Chair of Research Development and Innovation Committee, for introducing the webinar.
Thank you, Noella, and welcome everybody to this webinar 5. We have a challenge in front of us. It's a huge transformation going on, working towards emission-free Europe in only 30 years. And this webinar deals with the Vision 2030 of ENTSO-E, and we would like to introduce the thematic challenge, how to innovate, as one topic, and the area with the operational challenges we see in front of us, combined with the increased mix of HVDC and HVAC in the core of the grids. In today's seminar, I will open this now, and then I will give the word to Damian, who is the leader of ENTSO-E 2030 Vision Project. And I will take back the word a little bit and go further into the RDI roadmap towards 2030. Thereafter, second point will be presented by Jan Kostic from Acer, dealing with the regulation, how the regulation should be in order to enable innovation. And then we go over to the technical challenges, integration of power electronics and hybrid AC/DC network, presented by Wilhelm Winter, who is the convener of ENTSO-E IDIC working group, with security and system operation of tomorrow as the main topic area. And as item 4, we have Jens Jacobs from ENTSO-E, focusing on the real challenges seen from the system operation, who is manager of the RSC project. And then Frank Shepherd from T&D Europe, from the manufacturers, will go through the dimension of technology innovation for sustainable green power system, seen from the stakeholder view, and in particular from the manufacturers. And then we will have an open floor, and then we would like you to contribute. And then you need to use Slido, as explained by Noella, and please do that. And then we can have a dynamic and lively debate. And in the other seminars, that had worked quite well. But please do use the Slido and not the mic, because then it will be too crowded. And then in the end, I will sum up with a short conclusion and next step session. So then I think we just start. So first speaker now will be Damian Cortinas as leader of the ENTSO-E Vision 2030 project. So please, Damian, the floor is yours.
Thank you, Håkon. Thank you very much. Is the sound correct? Yeah, can you hear me? Thank you very much. So I am just going to walk you through very quickly the overall vision of what we are trying to do and to see how this webinar of today fits into it. For those of you who have been following all through the week, and we know there has been a huge number of you, and we thank you for that. You know this already fairly well, so I'm not going to go much into the details, knowing that we will come back again this afternoon. But if we see how the innovation challenge goes into the overall vision, for this you need to go back to the beginning. How did we do this vision work within ENTSO-E? But again, this is something we presented at the beginning. The thing to keep in mind with this introduction is that all our vision is based at the same time on some data from the scenarios of the future that we have put together within the community of TSOs, but also with all the other stakeholders at national European level, and with a lot of experts from the different parts of the business of power transmission and at large, in order to put together something that it's at the same time an expert base, but who reconciles political objectives and technical reality going to the future. So next slide. If we look at the main key drivers that were into the vision, and there are six of them. They have been the object of different webinars all through the week. Today we will be focusing mostly on the second and the last one that we have today. Is the fact that we are having more and more power electronics into the systems that makes that the system that was a system of alternative covering in the past now is going to moving towards what we call a hybrid AC/DC system with a lot of power electronics and continuous current coming into it, direct current. And the last one, what we call the operational challenges, this is something that comes more into the way we operate our business, the way we operate the system. There are mainly four of them: resilience, forecast, automation, and artificial intelligence. What it's common to these two key drivers is that there are challenges, but there are challenges that can be solved through innovation and the common innovation that we can do together. So if you just go to the next slide, another way to put together this vision is that this idea that when you put all these key drivers together, what we see is that the future is going to be what we call a true system of interconnected systems, with TSOs and DSOs, with onshore and offshore, with sector coupling and sector integration that goes beyond power, and with distributed flexibilities. And today we will be focusing on the system of systems of how do we do to manage a system that is at the same time alternative current and direct current, and what does it mean? How do you solve this? And how do you introduce all these operational challenges that are common to all the systems as they need to be tackled? Again, with a very important message that goes all through these webinars, is that we are doing all this in the end for the benefit of all European consumers, with the aim of facilitating the European energy transition. Another way to see this is the geographical scales that we can see in the next slide. That all the challenges and the key drivers that we see reinforce the fact that there are three relevant geographical scales that will have to work together. Is what we call the European, the national, and the local one. What we'll see in the next 10 years is that all these drivers goes into a direction of a reinforcement of the European and the local part. These geographical scales will have a lot of multilateral interfaces, and interoperability will be one of the keywords in order to make it work. And again, this is something we are going to see today in these webinars, with this idea that system operators, in plural, because there will be transmission, distribution, other energies, and other kind of operators, will have a key role to facilitate the working together of all these system of systems. Again, with the aim of facilitating the energy transition, and with this idea of putting consumers at the heart of the energy transition. This is the overall picture. This is something we want to remind in all the webinars, because it's important to see how everything fits into this vision. And what we're going to see today, and now I give a quick way again back to Hakon, is how innovation will be one of the keys to solve these challenges and to unlock all the opportunities that comes with them within the next 10 years. And we'll show you how all through this morning. So Hakon, up to you.
Thank you, Damian. So then I will give you a short description of actually what we have done in RDIC, which is a Research, Development and Innovation Committee in ENTSO-E. And it has been a pleasure to chair that committee for the last 1.5 years. And what we did was to, in a way, go a little bit back in the history, because we have made roadmaps earlier in 2012, 2016, and it has been in a way linked to the technologies we see as needed. What we did now was really to go really back to the core. How can we actually manage to cope with the transmission and the transformation over to a complete emission-free Europe in 2050? And then what is really needed? So what we've done now is really to drive it more into use case-oriented innovation. In a way, we don't have time to deal with technologies which are really not that important in order to solve the big issue. So we did this, and that has been, as we see it, quite successful, because then we can really show what we see as really needed, seen from the TSOs, in order to deliver this transformation. And then we have 3 clusters, and the first cluster is maybe strongly linked to what you talked about, Damian. It's really linked to the one system of integrated system, the holistic, large system we see in front of us, where the breakthrough innovation opens for new opportunities for system users, and where we have flagships. In total, it's 6 of them. I will explain for you. So the first flagship is really dealing with how to optimize the cross-sector of integration, the power to X, and really the large issues there. And the second flagship is more into the deep electrification and how to develop an ecosystem for deep electrification. And then we have another cluster, which is really linked to the grid as the backbone. We see that the grid is a critical component in the future. It's a lot of pressure in order to utilize the grid, and we lift up the grid as a cluster area with a separate flagship. And that is really linked to how to enhance the grid use and how to develop solutions in order to increase the use of the current grid, but also, of course, to add smart technologies like facts, power devices, flexibility, perspectives, in order to really maximize the use of the grid, but of course also invest in smart devices and solutions which can help to increase the capability of transmitting power in the grid. And then the third area is, in a way, we call it a little bit the black box, but it's really important. We call it the cyber physical systems. It's covering the topic of today in particular, because we will have more and more power electronics, more and more digital components. In a way, we melt together the electricity copper grid with the digital grid. And just talking about the flagship, we have one separate flagship for the offshore. As you all know, it was a seminar yesterday. It's so important to succeed with the transformation. We're talking about more than 90 gigawatt of wind, even only in the next 8 years or 10 years to 2030. And what we see is that we have a lot of hurdles there, how to cope with the interoperability issues, how to develop that technology. So it's a separate issue. And also we need demonstrators, we need prototypes, we need to show that we can run control systems independent on the different manufacturers. And that is not the case today. We are building a lot of HVDC today between the synchronous areas, but it's kind of lock-in situation with the different manufacturers. So we need to open up. It should be as easy as it is on AC side to really develop meshed grids on the DC side. And that brings me to the next flagship, which is flagship 5. And here you can see just an example for today's topics. The flagship shows how to enable a secure operation of the widespread hybrid AC and DC grid. We have some hybrid in the Nordics today, between Finland and Sweden. We have a DC link internally in this synchronous area. And we have some issues when we build DC links in Norway next to AC grid, and we have solved it in a way. But what we see in front of us is a much, much higher penetration of DC. And that's good, but we have to cope with it. So we have to be sure that we have the right technologies and we have the right solutions at the right time. And what Jens will come back to today is really to connect this to the operational challenges. And that is maybe the next slide in flagship 6, because we see that we are working towards a more and more automated operations of the grid, of course, because the renewable calls for that. It's too complex. We cannot run it as we have done today. So we're really looking for how to run the whole system more automated. But that has to be done in a way that we keep the resilience, we keep the robustness in the system, and we develop new solutions on that road. And here's a lot of milestones shown. And what will be the next is that we will make an implementation plan. Based on all these flagships, we try to bridge it over to the real implementation plan, and that will be done in next step. And as you know, this roadmap was presented in public 2nd of July, I think. I know we got a lot of positive response and some adjustments, and we will update it. And then we will make the next step as implementation plan. And Jens will come back to some examples later today. Next slide. So as a summary, if you look ahead towards 2050, we look for an emission-free energy system, and that calls for a transformation. And system of integrated systems is a key and is the center of this vision we see as a step on that road in 2030. And the roadmap delivered by ENTSO-E is a much more focused and user-oriented roadmap in order to succeed. And we have to say that we have to accelerate the innovation. We have to do it in a different way. And we also have to realize that we have to de-risk solutions on the road, like in the offshore grid. How to build it? We need to make transformation projects in order to show that it's possible to build it. And then I also would like to say that these flagships are an enabler to speed up, and it's focused on implementation, integration, and interoperability of technologies and solutions. And of course, we have milestones, and we would like to be as coordinated as we can between the stakeholders. And that brings me also to the fact that this is not a TSO work, it's really a collaboration work with the vendors, with T&D Europe, with Win Europe, with the universities, with the users, with the DSOs, and so on and so on. And that's why these webinars are so important. And that's why we need feedback, and we need to adjust, and we need real collaboration. And of course, we need funding, we need also money to do it. And it's also important that we link it to Horizon Europe, which is really streamlined in order to succeed with the energy transformation. And of course, then the money should flow to the right projects. And I would say that it's maybe more important in the future that the money will run into those projects where you can de-risk it, where it's a component of new technology. Maybe it's better that we do together between the TSOs and the stakeholders, and we get the right funding in order to do that de-risk process in a good way. So that could also be coupled to CEF. And of course, the regulation plays a key role. We need incentives, which are good as TSOs, and maybe we need to adjust that as well. I think we need to. We need to be more open that we are succeeding in taking and adopting new technology and new way of doing things without a negative impact when you look into the regulation. It should be a positive. And I know that Jan will tell about this after me. So that's actually a good bridge over to him. So I will come back. I then say thank you, and I will go to the next speaker, where I introduce. Hello, Jan, you are there? I can see you. So please, the floor is yours. Innovation in regulation, please.
Thank you, Håkan. I hope my mic is working okay now. We had some minor issues a few minutes ago, so
it's okay. Yeah.
We'll understand. Thank you very much. Okay. So, well, I would maybe like to start with sort of a basic thing, right? Something which is sort of the template we need to all understand before going into the depths of how regulation should stimulate innovation. TSOs and also any other regulated businesses are businesses, right? So they act as businesses. Their aim is to, well, do well in economic terms. So when Damian made the statements to the benefit of all consumers, I think this could only work if these businesses, which are regulated, not because, I mean, they are regulated because somebody needs to regulate them, not because, you know, they want to do charity work for the consumers. So only if regulators and TSOs work well together will we achieve this objective to the benefit of all consumers. And I think this is a very important point to make, because really understanding how utilities operate, how the regulators regulate them, is an important fact to take on board. But jumping straight into innovation here, so why should TSOs innovate? Why should they be innovative? Well, in most cases, I would say that the TSO classical grids, classical operation of the grids, which has been going on for, you know, decades and decades. So you have overhead lines, you may have some cables, you may even introduce HVDCs and things like that. But this is, I would say, normal classical physics, and this sort of works. This is part of the regulated business, and well, but it takes time. And I think the time to build all of these, I'm not sure we have it anymore. So we should be a bit more innovative. We should try to find new ways how to tackle, let's say, the obstacles which are ahead of us. And I think only by being innovative will we be able to actually achieve these green objectives that we have. I think that the bar was set quite high, and it's not easily achievable. And I think a lot of work will need to be put into this, a lot of effort, not only on the TSO side. Again, like I said at the beginning, the TSOs only do what the regulated framework allows them to do. So why aren't the TSOs innovative right now? Well, you got the hint there. I think part of the fault is, of course, in the regulatory framework. The regulatory framework should provide a correct incentive for the TSOs to put effort in innovation, rather than, you know, continuing putting effort in building new infrastructure. But of course, you need to take this with some reserve. Building new infrastructure is still a fact that needs to be taken into account. TSOs will need to build new lines. The demand for energy is growing. The demand for electrical energy is growing even faster, I would say, than many of the others are. So electrification, wind energy in north, consumption in south, and so on, all of these demands building new transmission. I think this is a fact, but to really mitigate, I would say, the situation, try to find the best possible solution, and really to work to the benefit of all consumers. I think innovation is a must. We can go maybe to the next slide. Thank you. Well, this first bullet point in bold, I decided to put this on because in the past, when we had, in the previous years, we had quite a few exchanges with ENTSO-E on why are the TSOs not really, being innovative? And usually the TSOs said, well, the regulators are not supporting us. And we try to look a bit deeper into that. So we checked with all of the regulators in Europe, what is sort of the level of support that is given for innovative projects. Now, of course, these projects first have to be proposed by the TSOs. And the result was actually quite, maybe even surprising to many, that approximately 80% of all of these innovative projects that were proposed by the TSOs were accepted by the NRAs. So they got the funding through the tariffs, basically. That's what I'm saying here. Huh? So what is the issue here? Should the TSOs propose more projects? I think, of course, if you want to have more innovation, you need to be innovative, meaning you need to propose more projects. I think that's a fact. Now, the other option would be also that the NRAs would sort of write a blank check to facilitate research and innovation. But going back to the statement of the benefit to all consumers, I have my doubts that this would actually be beneficial to all consumers. I think that, of course, regulatory frameworks should incentivize, but keeping in mind the benefit to all consumers, they should do it based on weighing the costs and benefits of each project. So what is the benefit of innovation? That's, of course, for each project to work out, for each project promoter, the TSO in this respect, to let's say investigate, to develop, to prove. And this is very difficult. I have to admit, proving benefits of innovation is a very, very difficult task. This was pointed out by many TSOs, many utilities in general, saying that, well, most of innovation leads to nowhere. So the benefit will not actually be there. I think any innovation or any innovative project that the TSO decides to go into needs to at least have the objective of being beneficial, maybe not in the first stage, but in the second, third, and so on. Some benefit needs to be there for the consumer, and if the benefit is there, and if it outweighs the costs of such projects, then of course there should be no problems of regulators approving such projects. You could go to the next slide, please. Thanks. But yeah, approving projects, approving the costs of projects, of course, this is part of the problem that we have seen already. We are right now in the process of investigating best practices within Europe, and this might not be sufficient. And why am I saying that this might not be sufficient? Is that approving costs of projects, whether it's CAPEX or OPEX or TOTEX or whatever, is, well, innovative projects costs are peanuts compared to costs of, huge infrastructure projects, cables, DC lines, converter stations, things like that. So actually, if you want to really stimulate innovation by just approving the costs, makes it a bit difficult for the TSO to go in that direction, because for their business, for the business decision of the TSO, getting approval of a relatively small cost, so that's actually the base for their remuneration, is sort of what I call a shot in the leg for the TSO's business, because only high cost brings high remuneration back. And then I think looking at the figures of TSOs getting remunerated for classical investments, infrastructure, costly investments, of course, this remuneration goes on for decades and decades and decades with a fixed, quite high rate of return per year, while innovation costs are usually quite low and get remunerated, within a year or two as operational costs, perhaps. So in order to really help stimulate, we should go beyond just allowing allowing innovation. So we should go beyond just saying the costs are lower than the benefits, thus the regulator approves the costs of these innovative projects. We should stimulate innovation. We should drive innovation. Innovation should be treated differently compared to classical investments. The stimulation should be bigger because the benefit to all consumers is bigger, or at least it should be. Now, for this to work, of course, TSOs and regulators need to work together, and it's not that easy. We all know that, right? So it's not that easy, and I'm not just saying TSOs and regulators or ENTSO-E and ACER. I'm saying between countries, within regions, and so on, because we live in an interconnected world. So if somebody does something, it affects everybody, and of course this is a very important point to take on board. Going to the next one. Yeah, and we're jumping straight into the conclusions. As mentioned, of course, the TSOs will act according to the best economic interest of their business within the regulatory frameworks. I think once again, this is so very important, because we need to understand that the remuneration of TSO business, basically investments, is based on costs of these investments and not on the benefits of these investments. And this is a problem. Why would you invest in a low cost solution being remunerated for this low cost solution, meaning that you will be stressed, you will need to operate at a much higher efficiency rate. It would be much more difficult for you to operate, much more stressful for you to operate, and you basically get nothing for that. So we need to find a way how to sort of bridge that gap. Bridging the gap between classical and smart solutions is I think one of the fundamental things that we as ACER and regulators need to find a way out, right? We need to find a way to make this bridge sufficient that utilities will really start to invest in innovation. And well, as mentioned, ACER is really working hard to identify best practices, and as you probably guessed through the presentation and the slides, we will need to go beyond the best practices. That at least is my expectation. The best practice might not be good enough, because I think nowhere in Europe are we seeing sufficient levels of really smart, innovative solutions being deployed. Yeah, throughout, well, any system, basically, either the TSO or DSO systems. And once again, I would like to state that TSO NRA cooperation is really the key to our success. We need to understand each other. We need not to push beyond what somebody is capable of doing, but we need to make this gradual move towards really a smart new framework, which would really help stimulate innovation throughout Europe. Thank you. That's all from me.
Thank you, Jan. That was a really great actually description of actually challenges we see in order to succeed with innovation, and we will come back to that in the Q&A. So then I have to tell all of you, please use the Slido, because it's maybe somebody who entered after 10 o'clock. So it's a Slido link in the invitation, so you can bring up all the questions there if you have any along this webinar, and we will answer them as good as we can in this Q&A session, and we will come back to that later, as you know. So next speaker, it's a pleasure to introduce Wilhelm Winter. Is really a driving force in order to really succeed with this work we're dealing with now, with the challenge with the large penetration of power electronics in the grid and interoperability stuff and all that, Wilhelm. So please, the floor is yours, dealing with integration of power electronics and hybrid AC/DC networks.
So thank you, Hakan, for the introduction. So my presentation is more on the technical side now, on the integration of power electronics and hybrid AC/DC networks. So I will talk in more detail about the challenges and opportunities of the power electronic dominated power systems so we will have in the near future. So this slide shows already that that the integration of power electronics is ongoing, so that the ratio of power electronics on the total installed capacity is increasing. So by 2030, but we also expect to go further to a CO2 neutral, let's say, power system or energy system. And on the right side, we also can see that a lot of new HVDC transmission capacity is already planned by 2030. So there is a real need to do something, and this is a real transformation, as I've mentioned already. So next slide, please. So next slide shows already the change in power generation structure, but also in the behavior and let's say in the characteristic. Yeah. So we have a lot of, let's say, power electronics already in the system. So if we look on the offshore side, there are, let's say, interconnectors to offshore. There are embedded HVDC is planned, for example, in Germany, but also between Germany and Belgium. And the key question are how to accommodate more power electronics in the power system, and what do we do to maintain the same levels of security of supply. Next slide. This is on the main operational challenges. So due to the massive penetration of power electronics. So traditional, the stability is more related on the conventional power plants, but the conventional power plants are more and more phasing out. So we have to clarify how to deal with these stability issues in future. So with the frequency stability challenges, for example, the voltage stability challenges, then control interactions, for example, also subsynchronous harmonic stability, voltage formation, and also protection malfunction. So all these operational challenges we have to cope with, and if the conventional generation will phase out, so somebody has to take over. Yeah, so responsibility for that. So next slide. So what are the future system needs? Yeah, so compared to the past, so we have an increasing demand on flexibility on the one side, but on the other side also on controllability, and some parts also observability. If you go into more digital systems, observability plays a dominant role as well. So, but good news is that the power electronics have a lot of potentials. Yeah, so the potentials of HVDC, but also of wind and solar can deliver the required functionalities in principle, and the appropriate planning is required. So what we have in the existing, let's say, large European studies like Migrate and Promotion. So we see already that there are high potentials on these controllability issues. So with new control concepts, but also on flexibility issues. We also saw it on the national implementation of the connection codes, for example, of network code HVDC in some countries, that new control concepts are already required, that there is also already a guideline for that, how to get compliance with that new control concepts. So there are in principle good news, so to go ahead, but a lot of challenges are in front of us. So next slide, please. So, and for this, we have, of course, a roadmap, as Hakun mentioned, and mainly in flagship 5, we have covered this roadmap towards a power electronic dominated power systems in hybrid AC/DC systems, with an enhancement of system stability, with enhancement of the system observability and flexibility, but also the need for tools and advanced models, and also the enhancement of the coordination. Next slide. So in parallel to that, we have also to think about more and more HVDC systems, so in hybrid AC/DC systems. So that means we are starting today with a single point-point connection, going further to multi-terminal systems, and maybe in the future, I don't know when this may happen. This is really a challenging issue. Also to DC grids, to larger DC grids, maybe to offshore grids. We had this discussion yesterday. So it's really important to go ahead with that. And so HVDC in principle offers a required flexibility for large-scale integration of power electronics and grid forming control already. And they can improve the overall AC/DC grid operation, and they can contribute to grid stabilization in principle. But here it's very important that we also can extend this multi-terminal system. If you start with 3 legs, that you can extend this, and the extendable systems are really important, and we have to work on that we have multi-vendor, multi-terminal, maybe also multi-purpose solution in the future. Next slide, please. So on the tools and advanced model side, so ENTSO-E has been working with relevant stakeholders like Team Europe, but also with Wind Europe on solutions already. So, but this is a very important point, that we have to assess so the security of the power electronic dominated networks. So, and for this, it's really important to have the right models and the accurate models there. So, data exchange between TSOs and the common library of advanced models will enable the effective network studies, both on a regional but as well on a pan-European level. So that's very important also to go ahead with that. And next slide shows also some elements we have to consider on the coordination side. So for example, between TSO and DSOs. So as it is expected that in the future generation will more and more located on low voltage levels, but also in offshore, so a bit far away from the transmission system. So we have to consider as well the other partners and the interfaces between the different, let's say, voltage levels in the security analysis. So it's really important, to get to cover also the dynamic behavior and the stability behavior of the overall system, maybe on the interface to the TSO or between TSO and DSO. So cooperation is really important, but also here I think we are on a good way. Next slide, please. So this is a short takeaway for you, as a summary and conclusion, what we can, what we presented today, and what is really important to consider also in the future. So first point is the power system is migrating from the traditional conventional generation-based AC system to a hybrid AC/DC system, which will accommodate a high level of power electronics. So the operational challenge due to the high penetration of power electronics are identified. That's clear. And the HVDC interconnectors in fact introduce a higher level of control possibilities, which can be used to enhance the system security of supply. So, but in addition, this utilization of the novel control concepts to effectively use the technologies available will have a significant impact on how to operate the electrical system and the energy system. So, and we have to cope with these challenges. So innovation and research and development in the electrical energy business is crucial. So interoperability, for example, and we have been working on that already, and there are large programs expected on that. And also the demonstration of this, maybe in a full-size real project demonstrator, will become really important. And this is a key to to go in the next years with a full-size demonstrator to have these multi-terminal systems, which also play a dominant role, and it's a must, yeah, to go into that. That this is extendable in the future, and that we can really build these large grids on the DC side to have this real AC/DC infrastructure. And then very important is ongoing cooperation. So I think we have already good cooperation with relevant stakeholders like Europe and Winthrop. This ongoing cooperation with various stakeholders is essential from the early stage, and I think we are very happy to continue this within the next years. So thank you very much.
Thank you, Willem, for a very, very interesting and deep and technical actually presentation. But it shows the importance of knowing actually the real challenges we see ahead of us in the polychronic merging into the copper grid. And I think we will come back further later today to discuss the impact of this. But I must also say that the Slido possibility is there, so also present your name. I just checked the Slido now. It was some anonymous people out there, but also explain who you are when you're writing questions. So we continue, and the next speaker is Jens Jacobs. We're dealing with the system operation. And Jens, please explain what you see ahead of us, challenges of the system operation in the perspective of Vision 2030. Jens, the floor is yours.
Yes, thank you, Hakon. So I hope audio is fine as well, and you can hear me. So also welcome from my side. Again, shortly, my name is Jens Jacobs, working for Amprion German TSO, and I'm also the RC project manager within ENTSO-E, but that's not the topic of today. So I was also involved in the development of the system operation Vision 2030, and just to make it quite clear, so we're talking here about in the next slides about the identified further operational challenges. So what does it mean? That means that, of course, all the topics or most of the topics you have discussed in the previous webinars over the last 2 days dealt with challenges identified in the ESO Vision 2030. But besides them, we identified a few others we thought or think they are important, which have not been detailed much more within the vision. So these 3 areas or key areas, main areas you could say, are managing and coping with threats to the power system, the automation and decision support, as well as complex forecasting. So these 3 areas do not cover, of course, all the challenges as said, but they are really considered one of the most important ones. TSOs have to be prepared and have a clear plan for addressing them in the future. So that's why the intention or the topic of the coming slides and the presentation I'll give you is now to link these 3 topics, definitely important to be addressed, with the topics identified in the RDIC roadmap, mainly flagship 6, as was introduced by Hakon in the beginning, mainly on enhanced control operation and interoperability, and how we TSOs intend to face these challenges in the future. So having given you this short introduction about this topic, we can come to the next slide, please. So starting with managing and coping with threats to the power system. So first of all, again, there's no ranking in these topics. It's just random, starting with this one, and which are the challenges affecting the TSOs here. So you can break down this topic of managing and coping with threats to the power system mainly into 3 areas. The one would be risk preparedness, system resilience, and in addition also system restoration. I think all of these 3 topics are well known by most of the people. Risk preparedness, we recently more or less had the development of the risk preparedness regulation in conjunction with the clean energy package, so there's a lot going on. System resilience also got quite, I would say, prominent in the last years, while the term of resilience itself was not or still is not so common within the power system from my point of view, but it really got a big issue or a big topic, I would say, in the last years. So there's a lot of work going on, and we even have a working or a steering group, system resilience, now within ENTSO-E System Operation Committee. And of course, then the topic of system restoration, which is well known for the TSOs, but also for DSOs and other stakeholders, where we have, for example, the network code emergency restoration, harmonizing and dealing with these topics. So all of these three can also be a little bit broken down in topics and kind of buzzwords as anticipation, preparation, absorption, adaptation, rapid recovery, and also sustainment of critical system operation. So all of these topics belong to these areas. And of course, I think everyone agrees and clearly has the idea itself that all of these threats, nevertheless, how you will cluster it, how you will break it down, are linked to physical as well as cybersecurity. So specifically also the cybersecurity part, and this is also linked to the coming slides later on, gets more and more important, of course, due to the fact that more and more data is in the system and needs to be worked with. So, but this as an example or as the main ideas about the challenges, and now about how TSOs are going to face these challenges. So first of all, you could say ensuring cybersecurity of control systems or control centers as one point. And again, sorry, just to clarify these topics you see here now under how TSOs faces, as well on the next slides, they are coming from the RDSC roadmap flagship 6, where you have seen in the beginning again the graph presented by Hakon. So a few topics related to the threats topic, cybersecurity for control systems. This, for example, is also a topic which will be handled and worked on quite soon. So this is of course also an important one, and one topic which is in the near future to be handled. As also explained by Hakon, so these are the plans, this is the foreseen, and now it's up to the TSOs to develop the real detailed implementation plan. And these topics, cybersecurity for control centers, will of course be one of the first ones to be implemented. Besides that, we have developing of cyber secure and resilient pan-European information and communication technology platforms for data exchange. As just mentioned, data increases, the amount of data, the volume of data. So we need to have accurate exchange platforms for that, which need to be secure, of course, as well. We have the topic of resilience toolbox to be developed to assist the system operators. So really to provide the operators in the control rooms with the necessary tools to be able to handle all possible threats. And as well, developing and coordinated quantitative risk management approach is an important topic to be done in the midterm, I would say. And last but not least, as an example, of course, here also it's not a full complete list of topics, but the main ones identified: development and deployment of high-speed protection and control for meshed AC/DC grids. I think this topic also links quite well to the presentation we have seen by Willem before. So all of these topics are foreseen by the TSOs. As said, now it's the next step to have really a clear, detailed implementation plan on how to do and what to do. And yes, thank you very much. Coming to the next slide, talking about the topic of automation and decision support. Also this topic, I think in general is quite known for most of the people. The challenges affecting the TSO here is, first of all, due to the digitalization, the impact on the system is in that way that more and more market players or participants in general are acting in the power system, which is positive on the one hand, but on the other hand, it also brings the complexity of growing data tremendously. So there's more and more data which needs to be handled, which needs to be worked with, which needs to be analyzed. So there's a lot of challenges related to that. And this kind of big data as a buzzword to be used is becoming increasingly important, of course, but also challenging to create a reliable picture of the situation of the system, so of the whole system. We have a lot of data coming in, and we need to put it into one general overview. So automated systems need to support the operators. I think this is the most important. We're talking about support for the operators to ease their life, which also benefits every one of us in the end. And this needs to be done while creating a complete picture of the situation. So the operators need to know everything, or as much as possible, about the situation. What are the influence factors, and so on and so on. So the data needs to be accurately presented and providing best possible option to the operators with this situation. So again, here, how we are TSOs intending to face these challenges in the future. Having developed a pilot for a fully automated decision support system for better supported decisions in the control centers. Of course, here we need to mention this is really a topic in the long run. So this is intended to be also due to the roadmap and the implementation plan, one of the topics, I don't know, one around 2030 afterwards. So there's a lot of steps to be done beforehand, and they are coming the next bullets, all in the end helping to achieve this in the future. Developing standardized data protocols, I think, is one of the most important topics, and also one of the topics which needs to be done in the near future, because yeah, people need to, or operators, everyone, stakeholders need to be able to work with the data, and you only can do that if you have standardized protocols, so everyone really knows yeah, how to use the data, is able to use the data, and does not have problems with different data formatting and so on. One important topic also, again, in preparation of maybe a pilot for fully automated decision support is the development, but also most important, training of AI-based decision support systems. And what we do not need to, which we need to take into account here, is that in that we have different aspects to be considered, and they are technical, social, but also the ethical aspects need to be fully considered here. I think this links quite well, and is a discussion everyone is aware of yeah, automated driving cars, about this ethical topic, and the same yeah, issue also arises for system operation, of course. And what is also really important here is that for the development and deployment of backup procedures for automated systems does not need to be forgotten, because of course we can develop a lot of things, but all of it needs to have kind of a backup plan in case it does not work. So we have this in the current way of working in system operation, but also for the automated systems there needs to be a backup. And important here also to state, if we have a look at the first bullet point again on the pilot for fully automated decision support, we need to be aware that the intention definitely is not to have replace the operators in the control room. You will always need the human in your control room itself as a kind of a safeguard. As we have, for example, in airplanes today, they fly sometimes already now fully automated autopilots, but there's always a pilot in the plane in case something happens and he needs to engage. So this is definitely something we have to take into account here as well. I will not detail or go into detail on the link to flagship 3, so we can come to the next slide then already. Thank you very much. And again, as the last topic identified for this section here, we have this complex forecasting. I think here it's important to state in the beginning, we're not talking about only weather forecasting, so it's not only about when is the sun shining or when the wind is blowing. It's about complex forecasting also in that relation, that we have a complex, that we have a forecasting for the system itself. We have, for example, in the regional security coordinations due to the system operation guideline and so on, and also manifested in the clean energy package, the short and medium term adequacy forecasting. So where we really identify and provide the operators or the TSOs with information about, is there potentially week ahead or different timeframes some adequacy issue within the TSO or within a larger region. This also is related to complex forecasting. So which challenges affect the TSOs? The quality of the process results depends strongly on the quality of the forecast data, on the input data. So this is also quite closely linked to the topic we had on the slide before with the automation and decision support. The results or the use of data is only good and only good quality if the input data from the beginning initially are also good quality. So this is really an important topic to be dealt. And of course, with that, minimizing the forecast error leads to a reliable process result. Increasingly critical to gain all the information, because it's getting more and more, as we said also, and as we all are aware of, it's more and more data which is out there, and therefore out of the forecasting and putting it again bringing it into one big picture is one of the most important topics to be dealt with. So we need to have all the data collected, at least those identified as relevant, and put all of this in one big picture for the operators to be able to work with. So and then of course on the weather forecasting, again, having the high volatility of the infeed, and also on the other hand on the consumption, which is getting more and more, for example, new integration of electronic vehicles and other topics in the future will challenge the operators to make the right decision. It's getting more quick changes and more volatile topics to be included. And finding suitable solutions from day ahead or even before to real time gets really important. So hence maximizing the accuracy of the short as well as medium term forecasting is of utmost importance. Of course, we all know that the closer we get to real time, usually the better the forecasts get. But it's even more important that we started in week ahead, of course, also day ahead, or even month ahead, year ahead, and so on, as much as possible to have forecasts already in an accurate way available for everyone. So here also how TSOs are going to face, sorry, just two sentences left. Development and deployment of enhanced methods for more accurate and wider representation of the grid is one of the key topics to be handled here. And as well, and again here, I think this also links to presentation of Willem and also what we have heard in previous webinars, fostering, enhancing, for example, PMU usage for wide area monitoring to be able to really monitor the system, forecasting the system in that sense. That would be everything from my side on the topics. Thank you very much. And I think, we can then move on with the next speaker, Hakon.
Thank you, Jens, for a very, very interesting and a good description of the challenges you see ahead of you. Looked into the operational dimension. And there's no doubt that we need to solve a lot of issues here. And I think then I will remind you that the Slido questions should be put there in the Slido and write the name. And we will, in about 20 minutes, have the Q&A session. So I expect a lot of good questions also for this very good presentation. So next speaker, we will go over to the stakeholders, and the key stakeholders we would like to invite today is, of course, the vendors, the players who actually gonna do a lot of this change. And it's a pleasure to say that we have a very good cooperation with TND Europe, and together with TND Europe and other stakeholders, we will make this happen. So, Frank, please, technology innovation, sustainable green power systems. The floor is yours.
Håkan, thank you very much, and ladies and gentlemen, welcome also from my side to this interview now. I'm very glad to be able to represent TND Europe. And as you probably know, TND Europe is, if you can switch to the first slide, please. TND Europe is the Association of the Electricity Transmission and Distribution Equipment and Services Industry. And based on my background, of course, I will focus on technical aspects here, talking about the technology innovations for sustainable green power systems. Can we switch to the next slide, please? And once more, please. Thank you very much. So TND Europe welcomes, of course, the ENTSO-E vision towards 2030. And we also especially welcome that it puts the focus on the integration of various systems and technologies, as is also expressed by the true systems of systems concept. And I'm glad to say that many of the important points that we see in this context have already been raised by the speakers before me today. But to sum up the T&D Europe perspective, I can say that first of all, we need innovative, reliable, and cost-efficient technology. So we have to have technology options to put all this in reality. But what's at least as important is that we have attractive conditions for all players in the market to invest into these technologies. And this, in the third instance, will only happen if we also have effective regulatory frameworks for operating the power systems as one integrated system in the future. And I can only support what has been said before in terms of collaboration, which is an essential part here of the overall activities. I can say that as a representative of the industry, T&D Europe is already contributing to many of these activities. And just to mention one example, we are currently developing together with ENTSO-E a work stream for the development of multi-vendor projects, multi-vendor HVDC projects in Europe. So please switch to the next slide. The utilization of renewable power sources goes along with replacing rotating machines by power electronics. And this was very nicely explained by Wilhelm before. And it's very clear that this means a tremendous change to the power systems. What we think is that HVDC as a power electronic system is going to play an important role in this overall process. And we see this because the technology is available today. We have optimized versions for different applications, like for cable and overhead lines. And we have a broad worldwide experience. And what I have put here on the slide is just the experience that we have with the offshore wind. So we have about 10 gigawatts transmission capacity already in operation or just under construction. And what we also can say is that when it comes to energy transport, then there's no more efficient means but HVDC to transmit energy over long distances or in case of subsea applications. So HVDC can be multi-purpose. So it can interconnect different synchronous AC systems. It can strengthen existing AC systems as an embedded system, or it can connect remote generation and load. We can switch to the next slide, please. If we look at the HVDC systems today, then most of them, with a very few exceptions, we find that they are point-to-point. However, as also already has been said before, multi-purpose HVDC systems will tend to be multi-terminal. So they have to have the capability to grow stepwise, and they should have the capability to be expanded later by new links. And we already have some good approaches in this direction. We have first multi-terminal systems that are already under execution or under development in Europe. We have some HVDC systems that have kind of a label multi-terminal ready, so they can be expanded. But what we have to see here is that in all of these present design approaches, the DC side system integration is always done by one manufacturer or one responsible manufacturer. And that means that also a future system expansion will have to follow the rules that are set, the technical rules that are set by the first vendor. We can switch to the next slide, please. And I think it's quite obvious that this has to change. So a new approach is needed here if we really want to develop HVDC grids that can be expanded. And those HVDC grids will no longer consist of point-to-point HVDC links, but of individual converter stations or individual stations in general, which are linked by a transmission line. And of course, this raises the question how to assure that individual converter stations that are typically provided by different manufacturers will be interoperable. And the solution here that we see is that we have to agree on standardized functional requirements for all necessary station interfaces at the AC and at the DC side. And the technical rules, the technical requirements for connecting new stations, they should be formulated and defined in the corresponding HVDC grid code, but in this case also for the DC circuit. And we are pretty aware that bringing the technical solutions from different vendors together also imposes some risks. But we are convinced that we can reduce the remaining risks here to an absolute minimum by appropriate step-by-step development of these functional specifications, and also when it comes to a real project, by a step-by-step testing, software in the loop, and last but not least, it's very important, as long as we don't have sufficient experience, that we do this also by hardware in the loop testing. What we have to say here clearly, this is not paperwork, and this is nothing that we can done in a lab scale. So it's a really European endeavor, and we need a real industrialized size project in order to make that happen. Let's come to the next slide, please. As we can see here, there is already some technical framework where we can build upon. We have a Senelec standard that gives guidelines how to specify such a multi-vendor HVDC systems. And this standard addresses all HVDC grid relevant aspects. First of all, the coordination with the AC system. And then it goes into the DC side specifics, main circuit design, controls protection, but also modeling and testing. So we can right away switch to the next one. When it comes to system integration, when it comes to the coordination between AC and DC systems, then there are certain technical aspects that have to be considered. And a converter station, for instance, connect to an AC grid, can exchange active power in either direction. It can take power from the AC system or it can feed it back. But within the DC circuit it is connected to, this power exchange has to be balanced instantaneously by another station or by other stations. And this is a matter of the HVDC grid control to do this in a coordinated way. So today we can certainly have DC choppers that take away some energy, but we cannot generate energy in the DC circuit. So overall coordination means we have to take into account this dependency. We have a very powerful function here. So if we consider that we want to share primary reserve between different AC systems, for instance, or if we want to damp power oscillations. So this all can be done in a very effective way, and it can be coordinated by the HVDC grid control. We can switch to the next slide to see another aspect of such coordination, and this is addressing what happens at the level of a converter station. So also at the converter station, we have some deep interactions between the AC and the DC side. So for instance, when it comes to AC frequency control on the one hand side and DC voltage control on the other side. So this can be managed by the AC-DC converter station control in a very flexible way, but we have to say to the converter station how we want to do this. And I think this is again subject of the overall coordination between the AC system and the DC system, because both systems have their requirements. And just to mention here, reactive power control and AC voltage control, this can be done largely independent from the active power. Let's come to the next slide, please. So as we have seen before, coordinating AC and DC systems or the AC and DC circuits is a key topic. And what we can say here in a single vendor environment, as we have it in most of the HVDC systems today, the DC side coordination is done by the HVDC system vendor. But of course, if we think about multi-vendor systems, something has to change here. And that brings some new roles to the TSOs as well as to the vendors. And what we expect is that similar to the integration that we see in AC systems today, we also have in the future someone, maybe a DC system TSO, who takes care of the integration on the DC side. It's very clear, and I can say that here, that the HVDC vendors are fully supporting this process. So this is nothing that can be done just writing down the rules. There is some big knowledge that has to be factored in, big experience from the vendors, and those has to be brought together with the system needs, with the AC system needs and also the DC system needs. Let's come to the next slide. what is addressed here finally is also the interaction with distribution systems. And it's very clear that distribution networks also host a large part of generation and load. And to achieve an integrated system of systems, HVDC will have to be coordinated with these distribution networks as well. And what I can say here again, it's all about at first defining the requirements, defining the functional requirements that are needed. And in this case, this can only be done in a joint effort between TSOs, DSOs, and of course, the vendors. And what is very important from our perspective here is that considering the volatility of the generation and load at the distribution level, appropriate observability and controllability is needed. And then this brings me to my summary slide. And so what I have summarized here are some key points. HVDC and particular HVDC grids in coordination with AC systems, with AC transmission and distribution grids, will play a key role in reaching the European Green Deal targets. And being an integral part of an automated overall grid control, HVDC grids can become the backbone of Europe's power systems, interconnecting different synchronous zones, strengthening existing AC grids, connecting large-scale renewables and remote loads. HVDC grids will change the roles of TSOs and vendors with respect to the DC size requirements. The key to all of that are commonly agreed functional requirements, which will allow the industry to develop compatible solutions while keeping the freedom for technological developments. We need an appropriate regulatory framework which stimulates the investments into new technologies and supports attractive business models. And I can only repeat that paperwork is not enough, that we need industrial scale pilot projects as a necessary step in ensuring scalable HVDC grids. So thank you very much. That's all from my side so far.
Thank you, Frank, for an excellent presentation. Well, I think you are right to the core of the issue here now. The complexity is increasing and we have to cope with it. And we have to play together. And definitely we have a very good relationship with TND Europe. And we will come back now to the Q&A session soon. But thank you very much, Frank. What we'll do now, we are actually a little bit ahead of time. That's always good. So we will have a Q&A session, and I've asked all of you to write your name in the Slido link and ask questions. And hopefully Norela has read through all these questions, because what we do now is to give the word to Norela to be the moderator, because I expect a lot of questions and we have to place it somewhere and somebody has to ask. So all the panelists should actually put on the camera so we can all see the panelists. And then we will keep time and we should be finished 5 minutes to 12. So please, Noella.
Thank you, Håkon, and thank you very much, audience, for posting your questions. I think we have interesting questions and quite numerous, so we will be busy for the next half an hour. But I would like to announce also something which we will try to summarize actually the things and the issues which were presented by the different speakers before. So we have also in Slido a poll. So please choose your priority measure for the implementation of innovation, but also for the implementation of measures which allow the integration of renewables into the power system by 2030. So this is the option you can find in Slido. And I will ask, in addition to Håkon, so all the other speakers to come on the screen, so to turn on the cameras. So I will thank you, and Damian as well. And I will go now to address the questions. So of course we mentioned that actually we will reward the the questions which were ranked first. And I think this is a question which should be addressed by all of you, if of course you deem necessarily. It's coming from Energieville, so KU Leuven, the university actually here in Belgium. It's regarding the North Sea regional control centers. I suppose that this is a question coming from the fact that most of deployment of renewables, especially connected to the transmission grid, will take place actually in the North Sea. And the question is how this regional control center could create the coordination of the power flows, but also how this will provide ancillary services and the countries which should be connected to this. So I will start maybe by asking these questions to Jens. And then Willem, please also come in. And Hakon, you are also part of the Nordic countries as a member, as actually coming from Stadnet, and Damian as well from system operation point of view. And of course, Jan and Frank, if you have reactions from regulatory perspective or from technology perspective. Jens.
Okay, so yeah, since you addressed me first, to be honest, this is a new idea from my side, but I'm also not involved so much in this topic in sense, so in general on offshore and also there in that region. But I think it, kind of a regional control center in that sense could make sense, having in mind what developments are going on there. But again, this is just one first reaction from my side, not being involved in discussions or expert at this topic here. I think colleagues much more involved in this offshore topic might have a clearer view on that. But I think it also, of course, puts in some complexity in that sense, that within the whole offshore development we have in the North Sea and also in other regions, it's not only on one TSO in the end. So there are a lot of TSOs, I would say, coming together in that areas. So what is important, and this is nevertheless, if we have a regional control center or something else in the end, what is important that we have a proper coordination here for sure. And this is, let's say, the most important from my point of view, which needs to be assured and guaranteed. I would leave it with that and give the word to the colleagues.
Willem, from your perspective.
Yeah. Yes, I would agree to Jens. So there are a lot of things are going on. Of course, there is a strong need of control, of these let's say offshore elements or let's say offshore structures. But I also think this question would be better located yesterday, in this offshore session. But in principle, of course, there are so many things are going on. I wouldn't exclude this that RSCs would be a good idea. But I'm more on the side on the development of the system. So from my point of view at TenneT, so I'm not really an expert on that to say this is a very good idea, and a lot of things are going on. So I would say I would leave it also to others to say something to that. Sorry.
Damian, I will turn to you like a system operation expert.
Yeah. Not really as an expert, I would say, but more as Willem said, this was a topic that came from yesterday, but it's not a problem because what we are showing is that all the topics in the end are linked, and this question really shows it. What's for sure is, as Jens and Wilhelm have said, is that when you see significant development of offshore generation and links and a network in general, you will need some kind of coordination to put there. The question is more, will we see a control center there? But to answer this question, you need to remind what's a control center for. Control centers are operating, what we have today as control centers is a way to operate a system where you have load, you have generation, you have frequency, and you have a network to manage. And in the seas, there will be a very different system, because you will have a lot of generation, you will have maybe a bit of load through hydrogen, but it's not so sure. And you may have a network that is mainly HVDCs, where the question of frequency comes differently. So maybe a control center will not be the solution for that. But for sure, it will be needed to have a stronger coordination between the control centers. And in the end, this comes to the questions is, do you need a specific control area for the network indices? Do you need a specific market area for the network indices? For the market, we are saying yes, we will need bidding zones, and this is something we discussed yesterday. So I invite those who didn't follow to look at the replays that we are giving there. For the control, I think this is more an open questions, and different solutions may come about. And in any case, a control center there will be a very different thing about what we mean by a control center on land.
Thank you, Damian. I don't know if you want to intervene. If not, I will go to the next questions for the sake of taking as much as possible. The next question is more related to innovation uptake. And of course, this will be first addressed to Jan, because you mentioned the dialogue between the needed dialogue between the TSOs and the DSOs. But of course, there are other parties which are around actually the power system. And the question would be if other stakeholders like grid users, consumers, and technology providers should not also be involved in this dialogue, which will look for the uptake of innovation in the future power system. Jan, first.
Yes. Well, regarding the first part of this question on how to actually, structure the dialogue between the TSOs and NRAs, it's not easy actually. It's we know. I mean, both the NRAs and the TSOs know it's often quite difficult to really fully align and understand each other. But I think through insisting on dialogue and also workshops like this help. And I think this is probably the most difficult part. Because it's I would say quite difficult to understand or to maybe see the let's say honest answers to these questions from both sides, honest, let's say, solutions to these questions, because it's sort of once you open the Pandora box, things start flying out. So it's not that easy. If you ask the TSOs, for example, a question, why are you not implementing this smart solution? They will probably not say because we are not being remunerated for that. They would probably say because we do not find it mature, because we do not have sufficient trust in it, because we, and so on and so on. Because of course the first question might lead the NRAs to say, well, if it's to the benefit of the consumers, you should do it, full stop. And this stops the dialogue, and this is going nowhere. So with this answer, I'm also trying to answer the other part with involvement of other stakeholders. I think at the very beginning, to sort of set the stage, we need to first see eye to eye between TSOs and NRAs. We need to really understand the core of the problem, and without blaming each other for it, we need to find a good solution. And then, of course, in the second stage, we need to understand, let's say, the world of possibilities of these innovative solutions which is out there. I think this step, of course, involves different players, different stakeholders.
Thank you, Jan. Hakon, any reaction from your side?
I think, well, it was clear that we are not in a vacuum here. I think the cooperation dimension is crucial. We will not succeed to transform the whole system in 30 years without being much more transparent on the real challenges. and we should be very open on the fact that the TSOs alone will not deliver, and the regulators alone will not deliver, and the stakeholders alone will not deliver. So it's really how to create a sound basis to have this collaboration, and I think we need to do it slightly in a different way than what we have done. We need to be much more proactive and much more open on the real challenges, and also be open on the solutions. So based on the discussion we have had, Jan, because we are discussing this actually with ACE at the moment, how could we create an environment where we actually are incentivized in a very good way to come up with new solutions? And the same will be the fact between the TSO and the DSO, because we need to solve this somehow in a more collaborative way, and we need to really show who can actually contribute and what. And just as an example, the work we are doing with T&D Europe now, which was presented, is one example where we actually really discuss things together. We need to change things, and the same applies for other stakeholders. So I really believe in showing the challenges and really be open on the solutions, but that we should be transparent on how to handle these issues in the coming years. And the roadmap is one attempt, because that is really showing what we see now. So please lean in and try to add, and we might adjust, but that's actually a very important communication platform as well.
Thank you, Håkon. I will come back with the innovation uptake a little bit later. So I will move now more towards the technical challenges we have seen actually presented by Willem and by Jens as well, also by Frank. So one of the questions which is coming there, and I will try maybe to group them, it's a system which is based on inverters, on power electronics. Of course, will lack inertia. I think, Willem, you mentioned that in your slides. So the question is, which are the solutions to cope with this issue, and how, for instance, the technologies which were mentioned by Frank can support that from maybe a control system point of view and protection system point of view. Willem.
So I think, yes, I think this question came from Siemens Energy. Is this correct? Yeah. So I think there are several measures, competing with each other. So it seems power electronic dominated solutions combined with the storage capabilities are developing fast. But also conventional technologies could be considered. Depends on cost-benefit analysis, of course. What is best opinion, the best option? But one thing is the key: all market participants have to contribute in order to get a CO2-free energy system. Control concepts summarized under the definition of grid forming control are assessed in large European projects, so like Migrate, but also on national level. So national implementation of the network and HVDC regulation considers already grid forming control capability, and the guideline how to get compliance with these requirements was developed for Germany, for example, together with all relevant stakeholders. So Frank was also involved into that. He's also from Germany. So important step is to get now into implementation and deployment as soon as possible. So we all have to move.
Thank you, Willem. Frank?
Yes, yeah, well, I can only support that in the future power system, all new devices, be it HVDC, be it the new generators, have to contribute to keep the system stable. That's very clear. And as said by Wilhelm, there are different technical options. That's also true. And maybe it's easier to provide a certain amount of inertia by one technology than what it is to another. So this has to be carefully evaluated. I think as far as HVDC is concerned, I would say this is certainly to a certain extent a matter of the controls, but it may not only be a matter of controls depending on the requirements. So, and that means before we can really step into the implementation that was mentioned by Wilhelm, we have to agree on the requirements, or we have to understand the requirements. And because this will put the industry into the position to develop the appropriate technologies. As a basis, we would just need what are the performance requirements and how are they measured. So I think this is something that we should focus on. There are, as always, many technical options, and they have different impact on cost and design. And this has to be considered and optimized.
Thank you, Frank. Before moving to the next question, please go to the polls window and choose your priority option for actually integrating renewables into the power system by 2030. So at the end of the Q&A session, we will show the results of the poll. Now, the next question is more related to a little bit to the market issues and to the automation of and optimization of HVDC links. So it's given the example between Germany and Belgium. So I suppose that Allegro, it's a project there. So which is using the market coupling. So how do you see actually this optimization automatically done inside the countries and the switching actions? So this is again maybe a question for Wilhelm. So sorry, Wilhelm, to pass to you this type of questions, many questions. And maybe Damian, if you want to say something, and Jens.
So I can say something to the automation, yeah, of HVDC. So we do not have so many embedded HVDC in Germany, so far as I can only tell about our experience. So, but we have some interconnectors to offshore, and we have already, so we are using already, let's say, some emergency control actions in that, yeah. So this idea also of netcode HVDC, yeah, to put some fast actions on HVDC in emergency situations, yeah. So this we are already doing. So it's not really on the market side, because HVDC interconnectors they will always put all, let's say, generated offshore wind energy to shore. Yeah, so this is not an issue. If you are in an embedded system, hybrid AC/DC system, of course, that's really important to go into that, to have an optimal power flow, to use let's say the fast elements, the power electronic devices, yeah, to control. So far they can do it, the power flows, yeah. And there is a very important study, which our program, or let's say project, which ended, I think, some years ago. It is the umbrella project, yeah, so a European level project. And there are a lot of information, a lot of assessment of these things, yeah. And the results show that this is really a good idea, yeah, to have these hybrid AC/DCs to control, let's say, better, to have a better controllability in the overall system.
Thank you, Wilhelm. For the sake of covering more questions, I will not ask maybe now the other panelists. I will go to the next question, which is again the uptake of the innovation. And of course, this is more related to Jan. So how actually the rewards for the TSOs and the DSOs, of course, to incentivize innovation will be developed. And yeah, what is the most effective for the most effective innovative solution?
Well, it's very difficult to say how they will be developed. We have two ways forward, I think. One is for the more risky innovations, where you need to sort of mitigate the risk. You may opt for these financing schemes, or maybe incentive schemes like Horizon, like CEF, the ones that Håkan mentioned. But in general, I think for smarter solutions, which are, I would say, mature enough on the market already, I think for those, we should really look at the cost benefits assessment for each of those projects and reward basically or repay the TSO more based on the benefits than on the costs. Of course, the costs being much lower than the benefits there. So I think if the TSO would be rewarded closer to the benefit side of the equation, it would really create a really strong incentive. Of course, these benefits would need to be measurable, would need to be approved by the regulators. So we have a strong need for a solid CBA to start with. So this is, of course, in more or less in the hands of the project promoters, that is the TSOs, maybe also with help of other stakeholders. But that's sort of the general idea. This is very preliminary. That's the direction we are currently investigating in Acer and with the NRAs. It's not a final decision, it's not a final recommendation, but it's definitely one of the possible ways to go.
Yes. May I add, Jan?
Yes, Hakon.
Because I think this is a very, very important discussion. And we talked about this a little bit open, Jan, the fact that how we actually have managed to move the technology front in HVDC projects we have been building between, you know, continental Europe and the Nordics. And that is, in a way, in a step-by-step approach where each TSO do take the risk, actually. So what we have done, we have built a very long cable between Norway and the Netherlands, and we have lifted up the voltage source converter technology to higher voltage levels. And that's done in a way where we control the risk by having high competence. But it's really a risk to do it. So how to actually enable us to share the risk more between many TSOs maybe, and create atmospheres where you actually can lift the technology front, where you de-risk, like in the offshore grid. That is a very, very strategic question in order to really enable us to do what we have to do in front of us. And that is maybe linked to the first bullet you just mentioned. The more risky schemes, you call it. But it's really important that we deliver on it.
Thank you very much.
Sorry, Noella, I just want to a very briefly reply to her. I agree, of course, the risk is one factor. We need to overcome that. You have risk investments, but you also have investments which do not carry the same level of risk that you are mentioning. And those investments are still not implemented to the scale that one would expect.
I fully agree. So it's actually just the two components. So we need to do work in a twofold way. Thank you.
Thank you, Jan and Hakon, for actually covering another comment which was on Slido. So regarding the de-risking actually element. Now I would like to go to Frank. I think this is a question I have heard myself for many years, at least 10, 15 years, the DC breakers, and how this is going to be integrated in a multi-terminal solution in the future.
Yeah, I think it's very clear if we have growing HVDC grids and we think of grids that span across the entire continent from north to south, then it's very clear that we probably not allow a single short circuit to affect all the converter stations. I think this is pretty clear. What we see is that DC circuit breakers have been tested, not at least as part of the promotion project, to switch off fault currents. So this is an important step, I would say, but it's not all, because if you look at the individual test scenarios, then we find that the individual solutions, and there are different of them, that they also have different parameters and operating characteristics. And those are going to have an impact on the overall behavior in the DC circuit and on the overall system design. So I would like to say here that it is very important to consider the system integration aspects of DC circuit breakers to do a next very important step before they can be implemented. And system integration aspects at the end means to agree on more or less standardized requirements for the switch off behavior and over voltages and things like that that come with the opening the DC breaker, but also protection aspects. So how about backup protection effects and so on? So there are many questions that require further investigations, and it's I think a topic that should be on the agenda now to develop this idea further. But what I can also say here is that all of that should not hold us back from doing the next steps, because I think what is most important today is to assure interoperability so that we are able to build HVDC systems with the systems and components from different manufacturers, converter stations from different manufacturers, and to first overcome the hurdles that we have there. And I think we already see some pretty good applications in Europe that do not require DC circuit breakers in the first place. For instance, if we consider putting wind farms along an interconnector or so, this kind of combining interconnectors with wind park connection. So things like that may not right from the beginning be DC breakers, and this allows us to focus on what's most important today, and this is to get the interoperability done.
Thank you, Frank. Now, a more futuristic question. What you think about having a global grid linking linked by HVDC around the globe for integration and optimization of use of renewables if we go really cross continent? So, Hakon, maybe I will start with you.
Sorry, you start with me. You want me to answer or?
No, Hakon.
Hakon, sorry.
Yeah. I think then we're talking about something beyond 2030. Definitely. But what I like with the question is that you open up the mind. So what we can say that what we know for sure is that we don't know about all the solutions ahead of us. And obviously we don't plan for this global grid, but there might be surprises down the road, and we should be open-minded. But if you ask me, I think we have more than enough to create a European energy system which is a leader globally. I think we can take the perspective of competition here because we have a very strong cooperation between all players and start there. And of course, you can argue that there might be time shifts to China. I have heard about that. Maybe they can send over the power during the night and we take it back and so on. I think that's a little bit step 5 and not step 1, 2, 3. Yes, that's a brief answer.
Thank you, Hakon. Now, Frank, coming to you as a technology provider, because you, of course, you are acting on all the markets around the globe. So, which is your view on this idea?
First of all, I also like the question, and to me, it sounds like a very attractive vision, and I would fully support what Håkon has said. Actually, very clearly, technology can do that. There should not be any doubt about it. But first of all, do we have the necessary frame conditions? Is there really a need? Is there a benefit in doing that now? And then I would fully agree that we should do this in a step-by-step way. And let's do the first steps in Europe. And we have clear targets in front of us with the first multi-vendor projects, and we develop that way, I think.
Okay, thank you very much.
Norela,
yes.
If I may just add,
yeah,
because
yeah.
It's completely true that the connections with North America and China are maybe just a distant dream now. But I would like to say that more closer to Europe, there are the connections with North Africa. That today you are seeing a lot of activity, a lot of projects, a lot of developments on there. It's not as far away. But it will be a first step in this direction, and you know, with all the solar potential that you could have in the countries in North of Africa, and there are a lot of ideas going on into this. There are a lot of challenges also, and also maybe to say that when you go beyond Europe, the challenges are not only technical or economical, they become also political. You know, the means to interact with the network from the other countries, this kind of things. So we need to find security solutions also in this case. But before going further away, there are more close neighbors where maybe we will see things in the next 10 to 15 years.
Thank you, Damian, for this reflection. Now I will try to go to maybe to the last one or two questions. One which is related maybe to you, Jens. So it's this relationship, so the decision support the relationship between persons, people, and the machine. And I would like actually to also Damian to comment on this question.
Yeah, thank you. So first of all, I personally think there needs to be an interaction in some sense. So it's not that, or let's say again, personally, as I have also experienced as an operator in the control room in the past, I would not prefer myself to really rely solely on automated systems itself. So there will always be a component of the human interface in that. And I also, again, personally rather like to speak about decision support instead of really automated systems in that sense. Of course, we are discussing it, we need to discuss it, but the main, and I hope I also mentioned it before, so the main really purpose here is having decision support to ease the life of the operators, to make be able to take faster, so to react faster to the systems, and to provide best possible options and the best possible solution to the operator itself. But for me, the operator, the man itself, the human being needs to be there all the time, for sure, because that's just maybe my missing imagination or whatsoever, and that. But of course, nevertheless, the discussion on artificial intelligence, which goes closely with that, of course, is ongoing, and also ongoing within the TSOs, also ongoing with my TSO in Amprion. We are talking about that, and I know maybe Damien can clarify or give some more insight here, because I know that RTE is also quite advanced in that, compared to others at least. But making it short, there is of course interaction needed. It's important that we investigate in this direction, but I cannot imagine that at one place or one point of time we will be there and not having any human interaction there anymore. So I hope it answers the question in that sense.
Thank you. Damian.
Just to complete, the issue will not be only technological of innovation, will be a human one in this case, and even I could say philosophical at some point. You know, I live in the south of France, in Toulouse. It's the home to Airbus, you know, the ones who make all the planes that we use in Europe. When you talk to Airbus engineers, they tell you that today most new planes could fly themselves from beginning to end. But they have no plans to keep up the pilot, because they think nobody will go into a plane with no pilot in it, even if it can fly itself. And this is more or less the same issue. You know, our operators in the control rooms, they are the ones who keep the lights on in Europe today. And we even if it's possible, we want to keep this responsibility only to a machine, even if it's a very intelligent one, but a machine that in the end, the problem with artificial intelligence is that you don't really know how the algorithm decides. I think this could be the main issue, and this shows that technology and innovation should always take into account the human part of the equation, and this is what we are trying to do here.
Okay, thank you very much. I think I couldn't take all the questions. There were many, but I hope that with the selection we made, we managed to answer more or less the issues which were addressed. Now I would like to close by actually showing the results of the poll.
We cannot hear you.
Maybe you can take on Hakon.
I think, Noella, you're muted. Okay, but can you just show the poll? Maybe we can
Apparently
see it.
there is an issue.
There you
So,
are.
Hakon,
You're
go
back.
to you.
No, we can hear it now. So just show the poll. Okay. I just, shall I comment it, Noella? What we see here now is a result of the poll, and definitely the AC and DC system enhanced use of HVDC and advanced control seem to be the one on the top. And with 37%, I think we made a clear message there that this is really a top priority linked to the implementation of the measures to integrate ambitious share of renewables into the existing power system by 2030, followed by coordination among TSO and DSOs. And the rest was pretty close for mastering operational challenges, regulatory framework, and commonly agreed functional requirements. Okay, then I think we can close this Q&A and go to the last summary, which is a very short one. I will do myself. So thank you all. Thank you to all the speakers. And I just have one slide. So can you just bring it on the screen? Thank you. As a summary of this webinar, I would like to underline the fact that this cooperation and the way we have to solve the challenges ahead of us in a collaborative way is really key in order to be successful in energy transformation. And what we've done today is to have a specific focus on the innovation challenge as such, and also the fact that the European power system will be more and more a hybrid, where we have a much higher penetration of power electronics with a mix of AC grid and DC networks. We have shown this hybrid AC-DC concept and focused on the operational challenges where we see a large penetration and integration of renewables, which are of course more complex to handle. And that this hybrid AC and DC system will require commonly agreed functional requirements. And I don't know how many times you've heard the word interoperability. It's more important than ever. We will not deliver this without doing that, as explained by actually more or less all the speakers. And we also need demonstrators, we need pilots, and we will do it. So it's not the fact that we cannot do it, but we have to focus on the same things, and this is really on the top of the list. And this operational challenge will be coped with by the TSOs, of course, and focusing on automation and the decision support, linked to the complex forecasting, but also the human factor, as explained very carefully now in the very last Q&A session. In the end, we are people and we have to be there, although it will be more and more automated. And we also see that HVDC grids will just develop, and it will just continue. And it's not that we haven't done it. It's a lot of HVDC between the synchronous areas, but it will be much more higher penetration, in particular linked to the offshore grid, but also within the areas, the synchronous areas in Europe, and of course, and also in the Nordics. And we have to cope with this in a way that we are open for new solutions, and we will deliver this, but be much more streamlined in order to succeed with the innovation uptake. And ENTSO-E has done a job there now to make it more relevant and make it more use case oriented, and you will find it on the web. Just look after ENTSO-E RDI roadmap 2020-2030, where the aim is really to accelerate the innovation in order to reach the climate neutrality goals. And of course, while keeping the light on, it should be a resilient system. And explained by Acer, innovation in regulation is key to ensure that we succeed here. And it's twofold. You have the smartness and to utilize what you can do, more or less, based on high maturity of technologies. Just use it and go for it. And then we have the more higher risk elements where we have other arrangements to deal with that, as also explained by Jan today. And achievements and cooperation here is really linked to a fundamental cooperation between the stakeholders. And this seminar is one example of that. And in the bottom, we shouldn't forget why we're here. We're here for the customers. We're here in order to make it smart and affordable and have a strong competition base in the countries in Europe, and that should never be forgotten. And how you can also see this nice picture of the roadmap. So, as a summary, I thank you all, and I would, as a very last note, mention that it will be a wrap-up seminar later today, 2 o'clock, where you can actually get insight into all these 6 webinars all together. So you're please welcome to participate there as well. So I wish you a very nice day. Thank you all, everybody. Bye-bye.